Kaggle is an online community of data scientists and machine learning practitioners which regularly hosts data-based competitions. Today, we're delighted to be joined by one of our colleagues, Rafael de Rezende, who's going to talk to us about a recent M5 competition that looked at the uncertainty distribution of Walmart sales. So Rafael, thanks very much for making the trip down the corridor to join us.
It's great to be here.
Perhaps just to start off, you could just tell us a little bit more kind of about yourself, a bit about your background.
So, I've been working here at Lokad for the past 3 years, I would say. I have a supply chain background. I'm an industrial engineer. And sort of in here at Lokad, my role has been changing quite a lot in the past. Right now, I'm a head of product development at Lokad. And sort of me and my team, we take on the very geeky topics of Lokad. We work on the time series forecasting. I also happen to work a lot on a multi-echelon solution, and finally also work with what we call the MOQ solve, which I believe we have already talked about here in the show. Okay, great. And Joannes, today we're going to be talking about a recent kind of Kaggle competition that was all about looking at kind of the uncertainty distribution of Walmart sales. So perhaps you could just give us a bit of an overview of the actual challenge itself.
Yes, and maybe about Kaggle itself. I mean, it's a very specific kind of subculture. So Kaggle is, probably in our audience, most people have never heard of it, but it's actually a fairly large organization now that has been acquired by Google. And what Kaggle is organizing is competitions, I would say, of machine learning competitions where you have to predict or forecast something. And the idea is that companies typically, in order to set up a competition, you need basically two things, which are one, which is a data set, so a lot of data, and you will need to forecast or predict something. And the second thing is large prizes. And here, for the competition we are talking about, there was like $100,000 in game. And thus, it's, I would say, it is a very, very competitive environment. You literally have several hundreds of people that are complete professional at it. It's like a high-level sport in a way. It's not exactly the sort of sport that you watch on TV, but nonetheless, it is a very specific discipline. And people have, I would say, there is like in this subculture, there are like ways to win those competitions, and there are some people who are very, very good at it. Obviously, they leverage. It's not exactly like sport because they leverage very recent publication, very recent algorithms that are just published. So it's very intriguing because the community that wins the Kaggle, I would say, competition, typically they are not researchers. They are not the people who are making the breakthrough. They are mostly, I would say, people that are very, very good at figuring out exactly what is the state of the art. So there are people who are looking at all the things that get published all the time, and they can pinpoint among thousands of competitions which one is going to be the state of the art. And then they have to do usually some extra magic on top of it to gain a 0.1 extra % of accuracy that let them win. So usually they have to identify what is the state of the art algorithm for this specific problem, and then they have to find, I would say, a small improvement, because all the other people also have access to the same algorithm. So you need to find a tiny thing that will give you a tiny edge, and you will be ahead of that. So that's okay. A very specific subculture, and it's massive. I mean, I know that some people have never been, I've never heard of it, but it's literally, I think Kaggle has more than 1 million registered participants, so it's massive. I mean, it's worldwide. You have people that are from all over the world that compete, even if usually the winners are from North America or Asia. But basically, it's a worldwide community of participants.
Yeah, I mean, it was purchased by Google not so long ago, so it's
yes.
Definitely on the rise. Johannes mentioned there kind of that analogy of it's almost like a sporting event. You've got sort of data scientists competing, but also collaborating, which I think is a really nice kind of analogy. So perhaps let's just talk a little bit more about kind of the challenge itself. So what were the key kind of challenges that you faced, and also kind of who were you up against?
I think the sport analogy is really good. I mean, Kaggle does feel like a sport indeed. You have what is nice in Kaggle, you have this very collaborative approach. You have people helping each other, and really, like, you can see like spending some considerable amount of time into helping other people get better. happens at the same time as what Joannes says, as with the brutal competition that is happening, because there is money involved and there's all the big organizations which are either sponsoring or watching closely what you're doing there. I mean, this is like I think the main Kaggle thing. I have to say that it was the first time our team was playing in Kaggle, so we were the Kaggle, like say, newbies, still the Kaggle newbies. But it was not the first time that our team was like in some sort of competition as per se, because it happens in supply chain to have clients which are going to challenge you, which are going to challenge your solution. So we have already been through together this sort of intense competition against each other, but I wouldn't say not to the same level as Kaggle. I mean, here we had like 9 other 100 teams. Before we might have had competition against 2, 3 other teams, so it was, and everybody was really like trying to help each other even more than on Kaggle. So there was competition before, so our team already knew each other, but it was not at all to the same extent as what we see in terms of competition as in Kaggle. I mean, another thing about Kaggle, which is interesting on the collaborative side, is that many people criticize Kaggle for the fact that this collaborative notion might actually hinder a little bit of creativity. What happens often in Kaggle, and I think it did happen this time too, is that some people publish some solution which is actually scoring very well in the beginning, and all of a sudden you have many other teams which start following, which drop whatever they were doing before and start actually following the same line. So they actually have this flock effect that everybody goes to the same side of the corner. So the collaborative notion is, I believe, what makes Kaggle successful, but it also sort of, I have to agree with those naysayers that say it sort of hinders creativity from time to time.
Okay, and what about it from maybe a company perspective? Like you've got these guys kind of working on their free time. What do you kind of think to that?
I mean, I'm very glad that they did. You know, I mean, it has never been, you know, I would say the Lokad strategy roadmap-wise to try to win those competitions. Actually, I did a few with much less success, I would say, during the early years of Lokad. And I realized that the problem of those competitions is that they don't necessarily fundamentally modify what is the state of the art. They clarify what is the state of the art. That's very, very good. So once you have this sort of forecasting, demand forecasting competition, you know, here it was, this, by the way, for the audience, this was this competition where the team led by Rafael ranked 6 out of 909 teams, so that their achievements, it was actually, it was intended as a demand forecasting competition. It turned out to be a sales forecasting competition due to the fact that they didn't properly factor out the stock outs. So in fact, they were forecasting the sales, not the demand, but that's a detail. Basically, it was like a demand forecasting competition of 30,000 SKUs in Walmart stores, 28 days ahead. So that was the scope of the competition. Now, when I said that's very interesting, those competitions, they reveal the state of the art, but they don't necessarily fundamentally modify state of the art. And it's very interesting that in this competition, that was the first time ever, to my knowledge, that they were using a pinball loss function as a metric to score who was winning. So that's very obscure. You know, that's literally the metric used to measure the accuracy. And I believe that Lokad was the first to propose, back in 2012, we had a public post that basically supply chain forecast needed to transition toward quantile forecast. Actually, later on, we said we had to transition toward probabilistic forecast and do even more things. But back, so that was 8 years ago. We said that we had, and by the way, those forecasts are very odd because they come with a bias on purpose. And for the audience that might be a bit confused, why do you even want bias on purpose for a demand forecast? The answer is because in stores, what you want is to have availability of goods. That's what you want to ensure. So you don't want to have a forecast that where on average you have the people will find what they seek half of the time. You know, that's not what you seek. You want people to have like a 98% service level or something, you know, where usually what they are looking for is present in the store. And thus you want to have a forecast with a bias, and that's technically it's known as a quantile forecast. And this competition was for me very, very interesting because it was the first time ever that there was like a public, I would say, competition where it was explicitly stated as a quantile forecast. And then you have to build the technology, the tools to solve this problem. And very glad and proud that Rafael and his team managed to actually, rank 6 and in such a brutal competition.
Yeah. So let's talk a bit more about. You mentioned your team there, that you were kind of working on it. So how many of you were on this team? Who was it else that you were kind of working with?
So we were a team of 4. It was me and 3 data scientists from Lokad, one which is no longer working here, but still came from here. So we had kind of like each one had a very specific role within the team. Or if I could talk a little bit more, you had Guilherme, who was working with me on the core model, on those like very small mathematical details on how we're going to tackle the problem. We had Katarina, which was bringing, as she does in here, her business vision to it, like analyzing the data, going through and seeing like what are the main points, what are keynotes that we should take from the data and be sure to to model things properly, helping us model things properly. And then on last, there was Ignacio Marin, who actually did I would say 80% of the real hard work. He was working as more like a data engineer this time. He really came and built our whole infrastructure for the competition. And so that was it. And okay. Me trying to get everybody to work together and pushing for it.
You're in charge.
Yeah, exactly. Trying to get especially keep people motivated, I think, is the main point.
So talk us through a bit more maybe about the kind of approach you took. How did it vary from kind of other methodologies kind of out there? What was kind of different? I
think let's go back to the sporting analogy. So if you take for instance Formula 1 and you take for instance a Renault car from Formula 1, you will see it's not exactly the same Renault car as the one you buy in the store. I mean, what you're seeing there is not, people still translate both Renaults, but it's not the same car. When it comes to this sort of competition, people tend to work more or less in the same way. They build methods which are extremely compute-wise expensive and which are great for the competition, but they're still not exactly what you're going to get if you actually buy the product in the end. There might have to have some changes because especially if you took for instance most of the top 10 winnings, people who were winning, the amount of time it took just for running this actually fairly small subset of data from Walmart, it was completely absurd. It was 10 hours of just for a very small subset. So you can see that in real life, they would have to have some changes. I mean, we took it in a different direction. What we did, and I think this idea was really present from the beginning, was that we wanted to roll the same theoretical framework that we do here on a daily basis and put it on track. So what we did is actually most of the techniques we use are really not far away from things we do on a daily basis. Of course, I mean, we might have changed the car to put a small sort of a race setup. We did some changes, took off the back seat and etc. to make it more performance to the competition. But if you really check what we did and what people are doing here on a daily basis, you would have to be an expert just to identify what is actually the difference.
Okay, so what you're saying is computationally, because there were only sort of 30,000 SKUs, some of those other approaches did work, but if they were kind of at scale, it would be much more challenging for them to kind of work in the real world.
I think so. I mean, I'm not saying they wouldn't work in the real world. I think it would be complicated. I mean, you have brutal maintenance. We, in Kaggle language, what we did was what they call in Kaggle pure statistical forecasting. So we were using low dimensionality methods, methods that have been known for a lot of time, but the way we cracked the problem was not sort of the data science mode. We were really the supply chain professional first. We came on with everything we know about supply chains and about our sort of intuition about the problem, because we have been already through many other sort of internal competitions before, so we know sort of how things behave, and that's really what we put forward there.
Okay, what were your kind of thoughts on this approach? Perhaps you could just give us maybe a basic overview about how you sort of saw it from your perspective.
So it's very interesting because in the top 10, so basically there was 909 teams that competed. I did not look at all the solutions that were provided. I looked at the top 10. So basically there were people that were better than Lokad, worse than Lokad. What was very interesting first is that if you look at the top 10 solutions, they are all numerically incredibly close. So basically, from number 1 to number 10, it's literally almost nothing. I think we were something 0.01%, beyond after the guy that was ranked number 5, and the guy that was the person that was, number 7 was like 0.01%. I would say behind
us,
what
yeah.
the team of Rafael did.
One
So you
SKU,
see,
yeah.
it was like the team that ranked number 1 was a few percent ahead, but it was still incredibly close. Overall incredibly close. So now I think there are I would say at least 3 angles in which those competitions don't reflect what you get, what you need to have in a real supply chain world. And I think the difference between having a Formula One and a car that you've just kind of tuned for the race is, I think, very accurate in this respect. There was actually three top concerns. First was, I would say, operational costs just to get results. The methods in the top 10, Lokad was the only one that did not have like insane compute cost. And again, imagine like a car that consumes something like 50 liters per 100 kilometers. That would be that. Something that is like 10 times more expensive than any car. A car that consumes as much fuel as a truck. Yeah, I mean, if you can do pit stops every 20 minutes, yeah, kind of great. But otherwise, no. And by the way, with cloud computing, those costs, they are very real. If you need to rent 1,000 servers, that costs a lot of money. Second thing is maintainability. Again, the settings are just, for example, if you look, and again, I will go through this Formula One analogies that I think excellent. A Formula One is super nice because it works on a circuit where the road is perfect. The road doesn't have even, you don't even have a 1 centimeter obstacle. Because if you had it, the Formula One would just, completely go off track. It's literally, if you were trying to run through a Formula One in Paris, for example, even the small bump that you have on the sidewalks would just actually damage the car. The car cannot suffer more than a bump that is even more than a few centimeters, because the Formula One is so close to the road. It's literally 1 centimeter away from the road. So if you have any obstacle, it would actually break the car. So obviously, if you decide to have like a normal car, you have a bit more leeway and you're not completely stuck to the ground. So you don't drive as fast. But guess what? If your road is a bit more bumpy, you will survive obstacles. So those models, what I'm talking about, well, in terms of models, that's numerical stability. So you need to have something where if your data is not perfect, if you have things that are, a bit of corruption, right and left, your model doesn't go crazy and you don't end up with completely, I would say, insane results, which would be, just like your Formula One going completely off track. So maintainability means that if you have conditions that are not ideal, it's still relatively, sane and conservative, which again translates in the fact that it will work because, again, in this competition, you can have people that are going to spend literally hundreds of hours on making sure that everything is perfect, just like, a racing circuit. But in the real world, you have stuff that happens all the time, and it's messy, and roads are not perfect, and everything. And that's translated into the fact that numerical stability is, less. It is very important to have models that are numerically stable, maybe a bit less accurate, so that when you have a bit of garbage, there is a saying in data mining, garbage in, garbage out. But the reality is that you always have a bit of garbage. So you need to have something that doesn't go crazy when there is a bit of garbage. And the last thing, which is also completely absent from this competition, is extensibility. The reality is that, for example, in this competition, stock levels were absent. Future promotion. So we had to, the team of Rafael had to forecast 28 days ahead. They had the pricing history, but they didn't have future prices. So the prices for the duration to be forecasted was 28 days. So basically, they didn't know the future promotion. So if we wanted to have like a real world setup, we'd have to embed stock levels, future promotions, and probably we would have like stock I would say, shelf constraints on how much stock you can have on the shelves for real. So that's constraints that. And then you would have, I would say, the loss that was used to assess the accuracy was the pinball loss. But the reality is that you can have all sorts of non-linearities that happen.
Okay. What are your thoughts now that the kind of competition is over? Joannes mentioned there those kind of like really fine lines of 0.01% to get into the top 5. Must be kind of frustrating. So are there any kind of thoughts on how you could have improved?
I mean, we have loads of like we had many things that we did not try during competition. Like at some point, you're reaching the deadline. You have to say, okay, well, this is going to be it, let's go with this, and we go. But of course, there are many ideas out there that we could have improved. I mean, I don't think this is going to be the next focus. Right now, the main focus will be to take the few improvements that we made from what we had, and try to bring it to the whole Lokad, to the other data scientists, and make sure that those insights, they get reproduced really quickly to all our clients. Which Walmart isn't, like, by the way. So we're going to take all the things that we learned and like try to put them to roll as fast as we can, and especially the knowledge, to share the knowledge with the others so that we can get more value to our clients.
Nice. And what about you, Joannes? Is there anything that you noticed the team do that you think is particularly useful for maybe the future?
Yeah, I mean, frankly, it was great. It validated so much of our approach. The thing is that when I say, oh, we need to have a model that is, super lean, super maintainable, super extensible. Great. Now you have a lot of constraints that are completely unrelated to the forecasting accuracy. Question is that when you take those constraints into account, how far are you from state of the art? That was the question, because you see, maybe the conclusion would have been, we have models that they have good properties, they are maintainable, they are lean, etc. But they are light years behind what you could get with state of the art, and that's the conclusion is the exact opposite. We are actually, literally a hair or two, of thickness behind what is state of the art.
I mean, I'd like to add the fact that it was a supply chain competition. I mean, like it is also like nice to supply chain professionals to know that actually, well, knowing your domain actually is going to help for something. Because we are competing mostly against people who are not supply chain experts. We're competing with people who are data science experts, and we were actually the supply chain professionals, which also happened to be data science playing in the field. So this is actually a thing that might have differentiated us in the competition.
Okay, great. We'll leave the kind of final word up to you. What's next for you? Have you got some more competitions on the horizon, or?
I mean, definitely not this year, no. I think, well, of course, there might be some challenging clients coming ahead, but I think in terms of competition, we had a lot of stress this year, so we're going to leave it to the next year, get some time to refresh, and then maybe next year.
Yeah, I think you've probably earned a bit of a break, that's for sure.
Yeah.
So I'll have to leave it there, but thanks both for your time. So that's everything for this week. Thanks very much for tuning in, and we'll see you again in the next episode. Bye for now.